Here is a little applet. These are nice, I don't know, Java applets. And I can change the angle of incidence, but what I want you to notice how the red, green, and blue bend by various amounts. Do you see the blue? Right? It bends the easiest. Okay? For some reason, it interacts with the electrons in that transparent medium, water, glass, whatever it is. It interacts and it slows down the most. It slows down more than red. And this allows me to change the angle of incidence. Right? So here's my angle of incidence. And then down here is my angle of refraction. And I can make it go much smaller. And then there's very little bending. And what does this one do? Just chooses, oh, maybe I can't. No, that one doesn't move. So then what we want to look at is rainbows. So on this one, you can see that from in air is not too much different than empty space. But what we know is that light from a distant star traveling through space all travels with the same speed because it comes to us as white light. But when the air, then when the light goes from air to water, then it starts to bend and it has this refraction right here. So you can see the colors separating out. But in a raindrop, what happens is this. Is that big enough? Can I make that bigger?
Yeah.
How do I make that bigger?
What's the chemical composition of outer space, deep space? Air and
You can hit it
there's no
again.
air in it, so what's the chemical
But I need it
composition
to
of
go to-
whatever's there? There's just
Or you
nothing.
hit the
There
negative.
are no atoms or molecules.
There's no atom in
I just want it there. There.
A few?
So
Zero.
look at inside that water drop. Do you see what happens? Here's the white light. Here's a refraction right here. Here's the reflection back here. And then here's another refraction. So that by the time it undergoes the two refractions, you get a greater separation so you can see all the colors of that spectrum. Now notice that this angle right here is not very much. It's only about 42 degrees. So the sunlight has to be low in the sky because by the time it comes back, it's only about a 42-degree angle from where you were. And there. Oh, okay, so that's that one. Now I want to go back this way. It is
The
my
bottom scroll bar.
There he is. So as the white light is coming in from behind him, anywhere that it makes an angle of 42 degrees to his eye, he can see that rainbow. All right? So the white light's coming in behind him. By the time it refracts and reflects down his eye, he sees that. Now what I wanted to show you in the aquarium is you can take an aquarium like that, and I put the aquarium on a cart, and I put a person with a black shirt on in front of a white board. And then you look at her through the prism of the aquarium. So if the aquarium is like this, you want to be,
You gotta put
There's
that
no
on.
computer back to.
oh, okay. So you want to be using like the corner of this. So even though she's sitting here, you can play around, we'll maybe empty the aquarium. I am going to be looking here because I want to see the light bend and bounce to my eye. And because of the refraction that occurs at both surfaces, thinking of that car window question earlier today, you get the colors separating out because the corner becomes like a prism. And surrounding each person will be a spectrum. And it's so amazing. So if you have black on a whiteboard, you see the spectral colors in one order. And if you have white in front of a blackboard, they flip. This was Newton's puzzle. This is what led Newton to take an ice pick and push it into his eye to see if he could change the shape of somehow the lens or whatever he was trying to change the shape of, to see if he could affect, was it only in my mind, right? He's a crazy guy. And But it's an amazing effect, and when you look through the aquarium, it's really quite stunning, quite beautiful. Yeah.
So how come sometimes when you see a rainbow, you can only see a couple of the colors, and not all of them?
So I think it has to do with the ambient light around the rainbow. Because there should always be a double rainbow as well. Because you can get two reflections off the back of the drop. You don't have to get one reflection. You could get that, right? So there should be another rainbow that you see as well. The secondary rainbow is almost never visible. So I think it's the ambient light in the atmosphere. I don't have a good answer for it.
And some,
Oh, go ahead.
how does the, presumably the circular shape of the raindrops account for the circular shape of the rainbow, but I don't quite get the geometry there.
The arc.
Or, yeah, why is it a circle? Or is it a circle, or is it a parabola? Why are they the shape they are?
I don't think it's
I don't know.
Looks like a circle, doesn't it?
I know you need the spherical shape of the raindrop to have the refraction,
It's gotta be that somehow.
like the convex lens, but as for the curve itself, I know that it's the 42 degrees by the time it does its thing. You know, the two refractions and the reflection. It has more to do with the law of reflection, why you need that.
But if everything comes up to 42, it automatically is a circle.
It's not, the average is 42, right? I mean,
But if it's
blue
all
is,
coming up relatively close to the 42,
right.
Does it have
Where'd
to
the
be
42
just where
come?
you're standing? The perception of it looks.
The 42 comes from this, right here, right? So as the sun has to be low in the sky, because by the time it bounces off the wall of water over here and comes back at you, it'll have deviated by about 42 degrees. Angle of incidence equals angle of, you have to be here. There's always a rainbow, you just don't see it.
Oh, so you have to wait until that time of the day?
Yeah,
so
because
it's
you're
that
low to
angle.
the ground. I mean, if the sun is up at noon, the rainbow's up there and you're not that tall.
I
Does that make
see.
sense?
Yeah, I'm trying to figure out why I saw big rainbows off the back of the paddle wheel on the river, or the 4th of July. It would
I saw-
crash in
yeah,
the
I
back
saw
and it would throw up spray, and all the little girls would go, woo, because it was
Right.
a rainbow.
So imagine that if the spray is not vertical like rain, what if the spray is like this or like this, right?
Yeah.
So then as the light, all you need is an angle of 42 degrees from the ingoing ray to the reflected
Yeah.
ray, and you have to be there to see it. So if the wall of water is changing its position, you could be in different places to see it.
And would you get some reflection off the water and then the water spraying too? You know what I mean? Like the sunlight comes in off the water that you're in, and then that bounces off
Right.
on the spraying water, and
Yeah.
that could even account for
Right,
the
another
42
secondary
degrees.
rainbow
like
that
a
you're
hose.
seeing.
Yeah, exactly.
Okay, that's another question.
But I was
Marty?
going to say, the other thing is too, a lot of times with rainbows, the rain doesn't come straight down. A
Right,
lot of times rain, so if you've seen it, and especially in the Midwestern prairies, you'll see the line going like this, so that angle can be.
And
That
what
doesn't make sense
about-
to me, that, because it's a sphere, doesn't matter what angle it is.